So we're talking about atomic radius. Radius means size. Okay, so wherever you see radius, that means it's size. So what does the size mean? Size means the distance from the nucleus to the outermost energy level. So if it is an element, for example, hydrogen. Hydrogen has only one energy level. And how do you know hydrogen has one energy level? Because hydrogen is in period 1. Anyone who is in period 1 has one energy level. So lithium is in period 2, it has 2 energy levels. Sodium, who is in period 3, okay, sodium in period 3, so it has 3 energy levels. Okay, potassium in period 4, so it has 4 energy levels. So do you see what's happening to the size as you go down the group? It's getting bigger. The size is getting bigger. And why the size is getting bigger? Because every step I'm taking down, I'm adding another energy level around it. Make sense? So that's all you need to know. That the size gets bigger as we go down the group because we add another energy level every step we take down. So what is again the definition of radius? The radius means that from the nucleus, what is the distance to the outermost energy level? So you see this distance is bigger than this distance, you know. This is bigger because it has 2 energy levels. So here the distance will be even bigger because there are 3 energy levels around it. So first of all, you need to understand what is radius and then what is the trend of the radius in the group as you go down. So it's getting bigger. Now what is the trend of the group as you go across? You see it is getting smaller. And why is it getting smaller? You know, we understand why it is getting bigger. But why is it getting smaller on the side, going to the right? The reason it is getting smaller going to the right, because if you look at the atomic number, every step you take to the right, you're adding more protons to the nucleus. You know, 20, 21, 22, 23, 24, you're adding more protons to the nucleus. So more protons to the nucleus gives more power to the nucleus. So if it has more power, it will pull the electrons inside. Electrons are negative, protons are positive. Okay? Electrons are negative, protons are positive. So they will pull the electrons inside. So if you have more protons in a nucleus, the more the power is going to be. So the radius decreases. The radius decreases. The radius decreases as you go down the group. Go across the period because we are adding more protons to the nucleus. So that's all the trend you need to know. That what happens to the atomic radius in the period, it decreases. And what happens to the atomic radius in group, it increases. So if I want to draw it, that's all you need to memorize. And if you memorize radius, it becomes easier for the rest of the trends. It is going to increase down and decrease across. Now you also need to know the trend, but you also need to know the reason. Why is it increasing down? Why is it decreasing across? Once you know the trend of the atomic radius, every other trend that we're going to study is opposite to that. So that makes it easy. Just memorize one trend, which is easy to memorize or understand, and every other trend is opposite. What is the other trend that we're talking about? The other trend we're talking about is electronegativity. But before I go to electronegativity and ionization energy. Electronegativity is the power by which the electrons are pulled. So let's say there is a bond between hydrogen and hydrogen. It's a covalent bond. Electrons are being shared. So what it means is there is one electron with this hydrogen, one electron with this hydrogen, and they're sharing it. So technically there are 2 electrons sitting here. Okay? Now this nucleus has proton, which is positive. Nucleus is positive, right? We understand that. The nucleus is positive because nucleus has protons and neutrons in it. Neutrons are neutral, protons are positive, that means nucleus is positive. So this nucleus is pulling the electrons on this side. This nucleus is pulling the electrons on that side. It's tug of war. Now who's going to win in this case? This is hydrogen. You have one proton here, you have one proton here. So nobody's going to win because power is the same on both sides. The pull is the same. Make sense to you? The pull on this side is equal to the pull on that side. That means nobody's going to win. So electrons will be equally shared. Equally shared between the two atoms. Well, before I move on, the pull by which the nucleus is pulling the electrons on its side is called electronegativity. That is the definition of electronegativity. The ability of an atom, the ability of this atom to attract the electrons in a chemical bond. So the ability of the atom to attract the electrons towards itself is called electronegativity. So the ability of this atom is equal to the ability of this atom because both have the same number of protons. Make sense to you? Right? Okay. What if we change the example? What if we say I have hydrogen and chlorine? Now if you look at hydrogen and chlorine, hydrogen has one proton, chlorine has 17 protons. Now tell me who has the power. Of course, chlorine has more power to pull the electrons towards itself because it has 17 versus 1. 17 students on one side, one student on the other side, tug of a war. No rocket science to figure out who's going to win. So, then what happens? What happens is that electrons are not equally shared. Electrons are kind of leaning on chlorine because chlorine has more power to pull the electrons over. Chlorine is more electronegative than hydrogen. So when electrons which are negative, they are leaning on chlorine, chlorine will get a partial negative charge. And hydrogen will get a partial positive charge because electrons are away from it. So this sign that I am drawing here is not 8. All I'm saying is that electrons are kind of leaning on chlorine, and that is given of chlorine is a partial. I'm making a partial sign. Okay, partial means slightly. So when I draw this very quickly, it becomes like 8. But what I'm saying is that chlorine has more electrons leaning on it. That makes chlorine negative, slightly negative, and it makes hydrogen slightly positive. That is called polarity. Okay, so that is making this bond polar. So what is making it polar? Different power. Power of this atom more than the power of this atom. So chlorine is more electronegative. Now what is the trend of electronegativity? Electronegativity decreases down. The trend is opposite. Okay, the trend it decreases down and increases across. It is opposite to the radius. Remember I just told you that atomic radius, the size gets bigger down, smaller across. Electronegativity, the electronegativity gets smaller down, bigger across. Why? Why that is the trend? Hydrogen has only one energy level around it. Chlorine has how many energy levels around it? Okay. 3. But maybe you will not understand this. But hold on 1 second. Let me take you to another page. Okay. Maybe here. Okay, this is the size of hydrogen. Do you see the size of hydrogen? This is the size of hydrogen is like this big. Okay? So this is, here is the nucleus sitting. Chlorine is smaller than hydrogen. So when the atom is smaller, that means the distance from the nucleus to the outermost ring is less. When atom is bigger, the distance from the nucleus to the outermost ring is more. Right? So if I have to pull the electrons inside here, who has more power to pull it over? Because this nucleus is closer to the electrons. If I have this big of an atom, then this nucleus is sitting too far. This nucleus is sitting too far from the electrons. Make sense? So you cannot really pull them towards itself. Are you getting my point? The nucleus that is sitting closer to the electrons can easily pull them over. So smaller the size is, the more the power is to pull the electrons over. Like closer you are to the center, the more you have power to pull it over. So that's what makes it is. The elements that are smaller in size have more power to pull the electrons over. So, going back to electronegativity, the trend is opposite to the radius. So you have to keep that in mind. Here is the trend across the period. From left to right, electronegativity increases. So, electronegativity increases and it decreases down. Okay? But the other trend we need to talk about is ionization energy. What is the definition of ionization energy? It is the energy we require to pull the electron over. Like sodium has one valence electron. If I want to make it a sodium ion, what I'm going to do, I have to go in and pull the electron out. Right? So the energy I'm going to spend to pull this electron out is called ionization energy. Now, if the size is too small, an electron is sitting right here, close to the nucleus, because nucleus is kind of holding it. Protons are holding the electrons. And then compare it with this. So maybe I'm pulling somebody from here, right? So pulling this will require more energy, or pulling this one that is distance so much, which one will require more energy? The trend of ionization energy and electronegativity. Ionization energy. They're opposite to the radius. It gets smaller down and it gets bigger across. If you remember, the trend for atomic radius was what? The size was getting bigger down and the size was getting smaller across for the radius. So what I was telling you before, that if you remember radius, you will remember everything else because they're opposite. So both of those values, electronegativity and ionization energy, are opposite to the radius. Do we understand these two topics? Ionization energy and electronegativity? I have a lot of... Alright, so let me clean that up and then go ahead and answer the questions at the bottom and then we will go from there. Next thing I want to learn is bond polarity. We've already learned bond polarity as I was talking about electronegativity. Polarity means poles, two poles, positive pole and a negative pole. Okay, a positive pole and a negative pole. Where are the two poles coming from? We just talked about hydrogen and chlorine. If we look at the electronegativity chart, where is the electronegativity chart? That gives you the electronegativity values. So whenever it comes to bond polarity, you will be given the chart. Nobody can memorize these values. So you're given the chart. The question is talking about hydrogen and chlorine. Okay, you need to look at the values. The value for hydrogen is 2.1. So this is 2.1. Chlorine is 3.0. That tells me up front that chlorine has more power to pull the electrons over. Right? So chlorine is more electronegative. That means the electrons are not sitting in the center. Electrons are kind of leaning on chlorine because it has more power to pull it over versus 2.1. So that means that this will become partial negative, slightly negative. This will become partial positive, slightly positive. Once again, why? Because it has more power to pull the electrons over. Okay, it has more power to pull the electrons over. It's not going to break the bond. The bond is still there. The electrons are still being shared, but they are unequally shared. Not equally shared. Okay, that is called polarity. You have created a polar bond. I will say the bond is polar. What does that mean? It has a positive pole and a negative pole. That's all you're doing. You have to get the difference between the two values. Okay, further. The difference between 3.0 and 2.1 is 0.9, right? You have to memorize this scale that if the difference goes from 0 to 0.4, the bond is going to be non-polar. That is not significant difference. But if the difference is 0.5 and above, okay, bond is polar. So it is polar 0.5 and above. It is non-polar 0.4 and below. Okay, above 2.1, if the difference is greater than 2.1, the bond is ionic, means it's going to break the bond, take the electron over. Okay, it's not being shared anymore. So you have to memorize this kind of scale, I should say, okay, that 0.4 and below, 0.4 and less is non-polar, 0.5 and bigger is polar, okay, equal or less, equal or greater. I don't know how to, maybe I could be wrong, I'm not a mathematician, I am terrible math. So however you want to do it, equal or smaller and equal or greater, it's going to be polar, equal or smaller, it's going to be non-polar. Okay, so you have to know this chart, and based on that, when you are given the question, you need to see the electronegativity difference. So, let's say you have CO2. The question is asking, is CO2 polar or non-polar? Okay, so I'm going to go back to the electronegativity chart. Carbon is 2.5. Okay, carbon is 2.5 and oxygen is 3.5. Okay, carbon is 2.5, oxygen is 3.5. So of course oxygen is more polar. The difference is what? 1.0, which is greater than 0.5. Okay, that means bond is polar. But please, the reason I mentioned it, you have CO2. That doesn't mean you take 3.5 and time it by 2 and make it 7. Okay, you're not multiplying it. All you're doing this is that, is this in the carbon dioxide, is this bond polar or non-polar? If this bond is polar, that means this bond is polar as well, right? So in this carbon dioxide bond, you remember dot diagram? Who is 3.5? Oxygen is 3.5. This is 2.5. This is 3.5, right? So who is going to be? Electrons are leaning on whom? Electrons are leaning on oxygen. These electrons are leaning on this oxygen. These electrons are leaning on this oxygen, right? This oxygen, these electrons leaning on this oxygen, and carbon is partial product. And you only do the difference once. You don't multiply that 3.5 with 2 because there are 2 oxygens. You only calculate the difference once. Am I clear with this? So with that is the bond polarity. Let's go back to that one. Okay, bond polarity. So polar bonds, 2 atoms with different electronegativity share a pair of electrons unequally, because electrons are leaning on one atom compared to the other. The difference in electronegativity is greater than 0.4, which is, I just told you, 0.5 and above. So if it is greater than 0.4, it is going to be electronegative. Okay, fluorine is the most electronegative element on the periodic table. Whenever any element is making a bond with fluorine, 99% of the time it is polar, because fluorine has a lot of power to pull the electrons over. Alright, so now I want you to answer these questions. Calculate the difference between the two. Like carbon is 2.5, hydrogen is 2.1. Okay, so 2.5 minus 2.1, the difference is 0.4. So 0.4 and below is non-polar. So that means this bond is non-polar. Oh, I'm sorry. Here you go, non-polar. Do we get this? Oxygen, I just did 3.5. This is 2.1. So what is that? Much more than 0.5? 1.4? Yes. So that makes it polar. Alright, this is what we are doing for this page.